Good morning, student. I'm Mr. A. Shukla. Welcome to the second part of number system. In this, we will be continuing with the previous chapter, continuing with the previous presentation. In this, we will be the rational numbers and the types, then conversion of rational numbers to the fractional numbers, then conversion of fractional number to rational numbers, inserting rational numbers between any two given rational numbers, then rationalization of the irrational numbers, rationalization of the denominators, laws for exponent for real numbers, and then followed by an exercise. Coming to rational numbers and the type, the definition: a rational number is a number which can be written in p by q form, where p and q are integers and q is not equal to 0. Then the types of rational number: one is the proper rational number, in which the numerator is less than the denominator. Then the improper rational numbers, in which the denominator is less than the numerator. Then mixed fraction, actually it is, for example, if it is a improper fraction, it can also be written as 1 by 5. In this case, if it is a improper fraction of the type 6 by 5, it can be written 1 by 5. And then the equivalent fraction numbers, these are the numbers which can be, for example, if a number 4 by 12 is given, it can be written in the lowest form as 1 by 3. Okay, these are known as equivalent fraction numbers. Now coming to the conversion of the rational numbers to the fractions. This is very simple. We just have to divide the numerator with the denominator, and if we get a terminating number, for example, in this case we have taken 1 by 2, and if we divide 1 by 2 we get 0.5, which is a terminating number. So this is the terminating fraction. And if 1 by 3, for example 1 by 3, we get 0.33, which is non-terminating or recurring number. It can also be written as 0.3 bar or dot. Then the most important thing to remember, a fraction can be terminating only if the denominator is of the order of 2 raised to power n into 2 raised to power m, where n and m can be any positive integers. If this is in the denominator, then we'll always get a terminating fraction, otherwise a non-terminating fraction. Now coming to the conversion of fractional number to the rational numbers. If the fractional number is terminating type, that is for example 0.25, then we have to divide it by 100, because after decimal there are only 2 digits. If there are 3 digits, we are supposed to divide it by 1000. If there is only 1 digit, we are supposed to divide by 10. Now for fractional numbers which are non-terminating and recurring, example 0.33, first we are supposed to assign a value to the number. In this case we say x is equal to 0.33. This is the first part. Then since only 3 is recurring, that is only 1 digit is recurring, we are supposed to multiply it by 10. If there are 2 digits recurring, we are supposed to multiply by 100. And if there are 3 digits recurring, we are supposed to multiply by 1000. Now this is the second step. Now the third step is we are supposed to subtract the first step from the second step. That is, we are supposed to subtract x is equal to 0.33 from the second step, that is 10x is equal to 3.33. So we will get 9x. After subtraction we get 9x is equal to 3, or x is equal to 1 by 3, as it is shown over here. Now coming to the next topic, that is inserting a rational number between any two given rational numbers. The first thing is in this we are supposed to, now in this example I'm taking example of 2 and 3. If the number of rational numbers to be inserted are 2, 3, then 1, 2 or 3, then it's very easy. The step is we are supposed to add both the given numbers and divide it by 2. So we can insert one number. If we are supposed to insert 3 numbers, then whatever number we are getting, we are supposed to add it to the lower number and then divide it again by 2, and then we get this 2.25. And if we are supposed to insert three numbers, then the first number that we got, we are supposed to add it with the upper number and then divide it by 2, we get 2.75. So it can be represented like this on a number line. That is, the smallest number is 2, then we get 2.25, then 2.5, then 2.75 and 3. Now if we are supposed to insert more, now if we are supposed to add more than three numbers, that is 4, 5, 6, or more than three numbers, if we are to insert between any two given numbers, we are supposed to follow these steps. The first is we are supposed to find the difference between the two given numbers. Okay, if it is 2 and 3, then the difference is 1. So we are supposed to find the difference. Then we are supposed to divide that difference by n plus 1. If n is the numbers, we are supposed to insert n numbers, then we are supposed to add it and then divide the difference by n plus 1 and assign it a value r. Now the third step is we are supposed to add r and its multiples to the smallest given number. Okay, now we will take an example. In this example, we will be inserting 5 numbers between 1 by 3 and 1 by 2. So 1 by 3 is smaller than 1 by 2. So the difference between 1 by 2 and 1 by 3 is 1 by 6. And once we divide 1 by 6 by 6, we get 1 by 36. So r is equal to 1 by 36. And if we add the multiples of 1 by 36 to the smallest number, that is 1 by 3, we get 13 by 36. If we add 2 by 36 to 1 by 3, we get 14 by 36. Then we get 13 by 36, 16 by 36 and 17 by 36, and next number will be 18 by 36, which is equal to 1 by 2. Now so our series, the 5 numbers that are inserted between 1 by 3 and 1 by 2 are 13 by 36, 14 by 36, 15 by 36, 16 by 36 and 17 by 36. Now coming to rationalization of irrational numbers, if our irrational number is under root a, it can be rationalized by squaring it. So the square of under root a is equal to a. And if our irrational number is of the order of 2 minus under root a, it can be rationalized by using the property a minus b into a plus b, which is equal to a square minus b square. So a minus under root a can be rationalized by multiplying it with 2 plus under root a. So it becomes 4 minus a. Now for rationalizing the denominator, if any denominator is of the irrational type, in this example it is 2 under root 7, then we are supposed to divide and multiply by under root 7 as it is shown. So if we divide and multiply by under root 7, it becomes 2 root 7 by 7. And if our denominator is 1 upon 2 minus under root 7, we are supposed to multiply it by 2 plus under root, multiply and divide by 2 plus under root 7. So it becomes equal to 2 plus under root 7 upon 4 minus 7, which is again equal to 2 plus under root 7 minus 3. Now the laws of exponents of the real numbers. Now this is the exponential laws, in which over here we have got a as the base. So a is multiplied 4 times. So this is equal to a raised to power 4, where a is the base and 4 is the exponent over here. Now the second rule is, if a raised to power 5 is into b raised to 5, this is equal to a into b raised to power 5. That is, if the powers are the same, then the bases can be multiplied and the power can be written only once. So this is shown over here. In this 5 times we have written a and then multiplied by 5 times b. So this becomes a into b raised to power 5. Now the third rule is, if the bases are same and then we are supposed to add the power. That is, if one is a raised to power 5, the other is a into a raised to power b, then the powers are added. That is a raised to power 5 plus b, and this is shown over here. 5 times we write a, and then multiplied by 3 times a, so it combinedly it becomes a raised to power. Now the next law is of the division law. That is, if a raised to power 4 is to be divided by a raised to power 3, then we are supposed to use a negative sign over here. That is 4 minus 3, this is equal to 1, and it is can be expressed like this: a raised to power 4, 4 times we have written a, and then we are divided by a raised to power 3, that is 3 times a, so we get answers a. And then next is a raised to power 4 into a raised to power 3. In this, again, a raised to power 4 is written 4 times and raised to power 3, so this is 4 into 3, this becomes equal to 12 as it is shown. Now we come to the end of this chapter, and I would like you to please try to solve few questions which I am giving over here. The first is, you are supposed to identify the type of rational numbers. That is, first is 7 by 9, 8 by 5, 2, 1 by 7, and you are over here you are supposed to write the sign, that is whether it is equal to, greater than, or less than. That is 4 by 9, this is a dash, and 12 by 27. Then in the second question you have to identify whether the numbers are terminating or non-terminating fractions. These are 3 by 6, 4 by 7, 3 by 5, and 7 by 4. Then in the third you are supposed to convert it into proper fractions. The first is 0.75 and the second is 0.47 bar recurring. Then in the fourth question you are supposed to insert 6 numbers between 1 by 3 and 3 by 4. The question number 5 is rationalizing the denominators. This is, the first is 9 upon under root 18, and the second is 1 upon under root 2 plus under root 3. Then question number 6 of the exponential type, in which this is 5 square whole raised to power 7, then 7 cube into 9 cube, 23 raised to power 10 divided by 23 raised to power 7, and the last is 17 square into 17 cube. You are supposed to write in the exponential form only. Am I very clear? So these are very few exercises. Okay, bye and good luck.